A box contains tiles numbered from 10 to 29. A tile is drawn at random and returned to the bag. The random variable x is the number showing on the tile. We want to calculate the following, but before we do that, let's just consider this distribution. So what we have is the probability of x being, now 10 to 29 is 20 different numbers, so the probability would be 1 over 20. Our x would belong to the set 10, 11, 12, and so on up to 29. Or it would be 0 otherwise. The probability x is equal to 13. Well, that's just one number. So it must be 1 out of 20. The probability of x equals 5, well, that's one number, but it's a number that's not in the domain, and therefore it cannot happen. So that is going to be 0. Now, be careful when we have a discrete distribution. The probability that x is more than 15 and less than or equal to 22 is the same as the probability of x being from 16 to 22 inclusive. In other words, we're looking here at it being 16, 17, 18, 19, 20, 21, or 22. Now you'll note that that is 1, 2, 3, 4, 5, 6, 7 values. So it's 7 out of 20. Now, you wouldn't want to write them out every time, especially if you were dealing with a situation where there were 40 or 50 of these things. So, we're going from 16 to 22. Do 22 take away 16? Well, we know the answer to that is 6. And then add 1, and you'll figure out how many there are. And that's how we could have got the 7 on top here. Now, the last part is a conditional probability. We want the probability x is more than or equal to 15, given that it's less than or equal to 23. Now, conditional probability, A given B, you should know is the probability of A and B divided by the probability of B. We're going to look at this several times in this section because this is often where students fall down. Not so much with the stuff that we're learning now, but with stuff that you should know from earlier courses. Now, in this case, the AND situation is that x is between 15 and 23 inclusive. And then on the bottom, we have that x is less than or equal to 23. So just consider how I'm following this formula. Now, as we just discussed for this one, we can do 23 take away 15 and then add 1. So there are actually 9 possibilities for the top here. And so we know that that would be 9 out of 20. For the less than or equal to 23 on the bottom, we know that's from 10 to 23. So we could actually write that as the probability that x is from 10 to 23. And then 23 take away 10, add 1 is 14. So that would be 14 out of 20. Now that simplifies to 9 out of 14. But let's just consider why that is the case. We're dividing fractions there. So we're doing 9 over 20 divided by 14 over 20. And remember, keep, flip, change, and then the 20s cancel, and we get 9 out of 14. So whenever you're in this situation here, you know that you can just flip it and get this situation here.